Hello math20-2, and today we're going to learn how to prove angle relationships. So the first page here just tells you exactly how to do it using a compass. So we're going to do our first practice question, which is using a compass. So here we go. Step one is we're going to draw a line. I could draw from here, as long as it goes through point P and it intersects this line. So I'm just going to go from here. Point P intersecting the line. There we go. Next thing I'm going to do is I'm going to make a radius somewhere here, and I'm going to turn it here so it's a bit easier for me to do. So go from the point, and we want to know the radius of this line. I'm going to make kind of like this here, an arc connecting both. So we've seen this before, and that is kind of my angle. Now, from point P, because this is going to be my new intersection, pretty much, is that point P. Point P is my new intersection. So I have my arc there. My distance there should be like that and like that. So from point P, we're going to want the same distance. Oh, my compass just shifted on me, so I have to measure. And it is around right. Ooh. Hopefully I get it right. It's around right there. So now I'm going to do the same thing here from point P though, because we want to keep the same proportion. We're just moving the angle to point P. Next part is, I want to know the distance between, I'm going to call this here A and B. So we want to know the distance between A and B. So I take my trusty compass, and I'm going to measure the distance between A and B. I get around right there. Good. So there's my distance between A and B. So now, from this point here, because that's kind of like my new point B, I'm going to make another arc. And that, oh, see where it hits there? That should be my new distance. So we just pretty much move this distance here. Notice that. There's my intersection of the arc. And we have that point to that, oops. There's my intersection of the arc, that to there. We did the same thing up here. Now we just got to draw a line from point P to this intersection. So my line looks like that. Now this arc here is the same kind of as that arc there. Therefore, these lines should be parallel. Because all we did was we moved this angle here up and there. And that's, or down I guess in this situation. And that's what makes them parallel. Very simple. So these two lines should be parallel. It might be slightly off because your compass, you don't have very high-end, or I don't have a very high-end compass here, so it shifts a bit, so it might be off by a couple millimeters every time. All right. So next is proving alternate angles. Okay, so we're going to prove that alternate angles are equal. So here we go. Statement 1 says angle 1 equals angle 3. Well, what is the reason? Why does angle 1 equal angle 3? Well, this has to do with a property we learned in a lesson before. Sorry about that. So, if we look at angle 1 and 3, they must be equal. Why are they equal? These are equal because they are vertically opposite. That's it. We learned that in a couple lessons ago. Now, let's take a look at this. Angle 3 and 7, they say angle 3 and 7 are equal. So if we have 3 and 7, why are they equal? Because they are corresponding. Because notice this one and this one, if we shift this line up, they'll match with each other. And the definition we learned earlier, in a couple lessons earlier, is that these are corresponding. Okay? So those are two of your things there. So that's how we prove it. You just have to say why. Vertically opposite or corresponding in that case. Now, here we go. Example 2. We want to prove that angle 1 plus angle 2 is equal to 180. If I look at angle 1 and angle 2, that equals 180 because they are supplementary. And also, it is a straight angle. Why are these supplementary? Because this is a straight line. Okay, so it's a straight angle. There we go. Now it wants to know, why does angle 2 equal angle 4? So angle 4 and angle 2, why are those equal? Well, those are alternate angles. Okay, because they're alternate angles. Remember the Z we did? These are alternate angles in the Z, because they're alternate angles. So it's very important you go over the definitions from lessons before. Okay? And then prove, this is the proof we know that they're supplementary, is that they're straight angles. These are equal, because, or straight angle. This makes a straight angle, a straight line. And this here is alternate angles. Okay, that's how we know they're equal. And then we need to prove that L1 plus L4 equal 180. Well, if we look at this, we know that 3 and 1 are alternate angles. So we know because 4 and 2 are alternate angles, are alternate. Oops, spelled alternate wrong. So we know since 4 and 2 are alternate and 1 and 2 are supplementary, 1 and 2, I'll put my angles in there just so we don't get confused. Angle 2, angle 4. And angle 1 and angle 2 are a straight line. Then angles, which ones were we doing? 1 and 4. Are supplementary. Okay? So pretty much that's how we did it, because we look at this. This is the same as that. Well, then we could put 4 and 2 are the same. These are supplementary, so then 1 and 4 must be supplementary as well. And that's how we do that, and we just write it all out. And I hope you have fun with your lesson. See you tomorrow as we work on the lesson together.